This is Dan Olds, and here we are again for another podcast. In this one, we're going to be talking to Carolyn Posty, who is CEO of Redline, about what students should be doing to get their clusters ready both before the competition and during the competition. After the competition, that's up to you. Hey, Carolyn, how you doing? Nice to talk to you.
Hi, Dan. Thanks for inviting me.
And so what does Redline do?
So Redline is a HPC services company. We were founded back in 1998, and we basically do design, implementation, and managing of HPC solutions and providing infrastructure management and technical support to some of the larger HPC sites, particularly the weather sites.
Ah, okay. So you know your way around HPC performance.
Yes, I do. Me, not as much anymore, but we have a great staff of engineers.
And I know that you've run this past your voluminous staff of engineers, and you've all come up with best practices and suggestions for the students, right?
Yes, we have. This was compiled by some of our top engineers.
So listen up out there. This is coming from top engineers from a company that's been doing this for decades. So this is the real stuff, the good stuff. Real quick, just going to talk about, we're coming up on the ISC competition, but everything we talk about in this webcast is appropriate for all the competitions. And just to dive right into it, so Carolyn, what should the students be doing before arriving at a competition site?
Well, we'll break it down into two sections, talking about the applications and the systems. So when we're discussing the applications, initially you'd want to get the code and take a look at it to see if there's any OpenMPI pragmas or GPU pragmas for OpenACC or OpenGL, and see if you can exploit those. You want to try running with different core and thread counts and GPU counts, because you may find that maybe more tasks with no threads or more threads and less tasks would be better performing. It really does depend on the application, and sometimes it also depends on the data as well.
So profiling the applications, but then going ahead and trying some of the permutations between threads and no threads. Mm-hmm. Right,
threads and no threads. But yes, and that you can profile your applications actually with a tool called TAO, which is Tuning and Analysis Utilities, to determine if there's any memory, I/O, or communication bottlenecks. Okay. And then you can go in and tune those sections of the code. And that's one thing that you may want to look for is, for example, some things such as collective communications create a bottleneck. Those are expensive, like all-to-all calls.
Okay.
And as the task count increases, that's much more communication. So if you can eliminate all-to-alls, that's good, or make them asynchronous, like remove all blocking calls and see if you can do work at the same time you're doing communications to save some time.
So Carolyn, the big thing that these kids are battling is that power limit of 3,000 watts. And that's something they have to keep in mind at all times.
Oh, yes. And that is, you have to keep your power profile. So that's where you may want to look at taking advantage of the GPUs. They use more power, but you may be able to run fewer tasks. So that's one thing to keep in mind, is that however you exploit your code with fewer tasks and maybe more GPUs, it may be the same power profile, but give you better performance. So that's why you really need to try some permutations.
And some of these new GPUs are taking like 180 watts, which isn't so bad. And they idle way down into 2 or 3 watts, from what I'm hearing.
Right. And then also regarding the, you may even want to declock your CPU. that has a power saver mode.
Mm-hmm.
You may want to make sure it's kind of detuned if you want to have more processes,
Mm-hmm.
right?
Mm-hmm.
So you may find that you want more MPI processes, and so if you detune your clock, you can get more and not really hurt the still gain performance.
Mm-hmm.
So it really is application dependent. So that's another thing to consider.
And it sounds like a lot of this is going to be essentially setting up a spreadsheet with a bunch of rows and columns and going through these permutations to find out what helps and what doesn't.
Oh, yes. Whatever you do, I would say to, write all your runs down and all the details of what you did.
Very rigorously.
Very vigorously, so you don't end up repeating what you had done.
Yeah, and it's one of the things that I see when I interview teams is they say, well, it seems to run faster when we did this. And I'd like to hear something a little more like, we know it runs faster when we do this because of our testing.
Right. If you record the times for everything, it's always better to have something quantitative.
Yes.
And a metric. So that, and you know what, if you graph certain things, that's one of the things of doing different core counts and different thread counts. If you graph them visually, you may get an idea of how the application behaves and how it will scale.
That makes a lot of sense. And you also say try different compilers.
Yes, to try different compilers. Our engineers have tried GNU and Intel and even different versions, because if you have a code that's not exploiting newer features,
mm-hmm.
if you have a code that's old, let's say, or it's fairly simple, you may not need all the complicated bells and whistles in newer compilers. And that could
save some time.
Yeah, it could save some time. Going back to an old compiler seems, that wouldn't make sense, but that it can give you a little better performance. And also, if you trying different versions and different compilers, and also the different optimizations, the same kind of holds true for the different optimization levels, that you don't necessarily have to use the highest. That may not give you the best performance. So you want to try different optimization levels as well, from 02 on up through 05. Because you may find that 02 gives you the best.
That is something I hadn't thought of. That's a good point.
Yeah.
And do you say also in our little outline here for the call, go check the internet?
Oh, yes. That is, go check the internet to see how everybody else has run these and if they have any hints and if they've made any discoveries.
And see what problems they may have had.
Yes, because they may give you some hints, see what problems they have had, because they may give you hints that will help you in the competition of maybe how to look at the data.
The other thing, too, that they can do is most every application we run in these competitions is open source. They can reach out to the people that wrote the applications and ask them for advice.
Oh, absolutely. And I have found, and so have my engineers, that people that have written these applications are very happy to discuss them. Oh, yeah,
I would if I had done something like that. One of the next section here is talking about hardware. And I don't think that they pay all that much attention to the hardware, enough attention to it. After it's set up, they just sort of assume that it's running as it did at school.
Yes, and that is something that Redline really focuses on, is performance. Mm-hmm. And when we build a system and maintain it, the thing to do, the key to do, is have system benchmarks that will measure the performance of your components. Mm-hmm. Because your application, if you don't know that your system is set up right, your application is not going to run very fast. So there's a series of benchmarks that we use to test systems and check their performance.
Yeah, what do you use?
Well, we use, to check the nodes, the CPUs, we use LinPack. And what we look for is to see if they're operating within a few percent of each other. Because, again, you're only going to run as fast as your slowest node.
So you're running LinPack on each node individually?
Yeah.
Okay.
Yep.
Good.
Run it on each to check the performance of each node.
Okay.
And use Stream to check memory bandwidth. That's an application that's available. And one tip is to be sure to build it with the correct memory size.
Yes.
It's easy to forget. So use that to check your memory bandwidth and get the information from your vendor as to what you should expect.
Okay, good.
Yes, and what you should expect for LinPack. They probably have run it, so they should tell you what you can expect. And IOR for your parallel file system performance is a common benchmark.
Okay.
So, yeah, you can make sure that your parallel file system is configured correctly and getting the most, getting the most out of it. If some of your benchmarks do some,
sure.
I mean, most of them are going to have to read data. You want to be sure you're going to be reading it effectively.
As fast as possible.
As fast as possible, right.
And then the Ohio State benchmark as well, right? The whole
Yes.
suite for InfiniBand or the Intel MPI benchmark. That's a great idea.
Yes, those have proven to be helpful because, if you've got a bad cable, you want to know.
Yes.
So,
yes, you do.
Yeah, if you have a bad cable, you're going to want to know. So you can check out the performance and see the latency and run a different set across different nodes and see how the communication is performing.
Mm-hmm. And you also said that there could be some issues with brand new systems.
Yes, we have found some to have DIMM fallout and processors overheating. It's just the initial fallout from a brand new system. Mm-hmm. So you may want to run, what we do is we run LinPack a lot when the system first comes up to burn it in.
Okay.
So we can find out what the initial fallout is. And so that way, if you see something, if you have a bad node or a bad process, you can take it out of your suite instead of letting it affect your benchmark. You cannot use that node.
That's a good idea. Then you have one that is very important in building big systems, is validate all BIOS settings.
Oh, yes.
That's one of the things a lot of people might not think of, but that can cause huge problems that are hard to trap out.
Oh, yes, because if you have, like I said, you can have your systems in a power saver mode, or, you can choose a speed for your processor. And you want to be sure they're all at the same speed, whether you choose to declock it to save power or not.
Mm-hmm. And, of course, dry run everything as much as you can before the competition starts.
Oh, well, absolutely. And what I would do is tear it down and build it back up several times.
Yes.
And keep your checklist handy.
Yes.
Make a procedure again, and then each time you go through it, modify it and put in all the gotchas. Yes,
and that's really important. One of the things that drives me up the wall is some teams occasionally, I go around and interview them all about how they're doing. They're saying, well, this application, we couldn't get it to compile. How the hell can you not get it to compile? What happens there?
Well, it depends sometimes on the version of compiler you're using, because initially it may have been built with a different version than what you're using. So there could be some standards that had changed and are now being enforced, so there needs to be some code changes. So that's something, if you know that's a tip. If you know how this code was compiled and tested, what version, then that is what you should try to use.
Yeah, I mean, and this is assuming that they were obviously able to compile it and use it during their practice before they got to the competition. So it's kind of like a kid showing up at the SAT test without a number 2 pencil. I mean,
you have to do this.
Yeah, you have to do this. So make sure your stuff compiles. And the other thing that I would tell everybody out there is, you have a lot of software, you have a lot of packages and tools and things that work. Put them on a thumb drive and bring them to the competition, or a few thumb drives. Don't come to the competition and necessarily think that you're going to have enough internet bandwidth from minute 1 to be able to download the 4 or 5 gig that you might need.
Oh, that's a good point.
Yeah, bring it all with you. Because
bring it with you. And when you mentioned about compiling the codes, I was, and it not compiling, I was thinking of what they're doing when they get their the unknown benchmarks, the mystery benchmarks.
Oh, yes.
That's more what I was thinking of, because I would assume that you want to come here fully prepared and have tested your code thoroughly before you get here.
Yeah, you would hope so, but some of them has some problems. But on those mystery benchmarks, so would that be essentially the same process that you laid out, only accelerated, of trying to profile the application?
Yes, you may not have time to profile. It all depends. It may just be running with different core counts and tuning it. Mm-hmm. Yeah, I mean in optimization levels. So you may only be able, if you had to pick some things, look to see if there's already code in there again for OpenMP and MPI and GPUs, and mm-hmm. see about testing those and trying with different levels of optimization and core and thread counts. And if you can do profile the application, if you can do it pretty quickly.
Yeah,
I think the thing
hard to say.
Well, that's the thing is, I don't know the timeline they're using or how much. So basically, I would say come to the competition with a plan in mind of how much time that you're going to allow. If you know how long it's going to take you approximately to profile an application, and plan out your time and see if you have it. And if you don't have enough time for something, move on to the next step.
Now, let's say they gave them 3 hours for a particular application. Would you devote an hour to profiling it, or half an hour?
Yes, I would. Depending how long the application took to run, I'm assuming
that's
it's
a good
only
point.
going to take a few minutes. Yeah, because really, if it takes a long time to run, you're not going to get much time to profile. You're really going to have to try to take a look at the code and see if you use OpenMPI and MP and OpenMP and.
Yeah, and typically at the competition, when they throw them a mystery app, the reason that they do that is to see how well the kids can think on their feet and how well they can do this stuff. And I think that they typically do have an adequate amount of time to do those basics, and then be able to get a data set or 2 in.
Well, I think then, obviously profiling gives you the most information about the code and about how the code performs. But you would, if it has threads too, you may want to profile it in different formats, running with threaded or not threaded.
Mm-hmm. Well, I think that brings us to arriving at the competition site and setting up your machine as quickly as possible.
Right. So that's what you want. Yes, that's the goal, is to set it up quickly as possible. And really, I can't emphasize enough to run the system benchmarks for the
Stream and LinPack and IOR.
Yes. Please run those so that you have everything configured correctly. And if you can find out what you should expect from your vendor in this, what the performance should
be.
should be from your vendor that's supplying the hardware.
And then if this is a new system to you, check and make sure that all those BIOSes are the same.
Oh,
that's
absolutely.
a very big deal.
Yep.
Yeah, that's huge.
Yes, that's huge.
And then you say, it's kind of interesting, you said in our pre-call, run LinPack when you're not using the system.
Right. So that was suggested. This is what our engineers do to break in a system for the fallout. So if you run it, you can find what's going to be, you can determine if there's a processor that's overheating and declocking, and then you can remove that from your configuration.
Mm-hmm. Mm-hmm.
And so it's all in doing a burn-in.
Okay.
So, yes. So we call it a burn-in process so that we can make sure everything is running optimally.
And if they do a good job of getting their machine set up quickly enough, then they should be able to have some time to start running their benchmarks and get those going as well. Make sure everything compiles and everything runs, all of that. They need to use that time.
Oh, absolutely. And I think this all comes into planning your time.
Yes.
Right. If you get the system set up, plan to run the system benchmarks to verify it, and then plan to run work on the competition benchmarks, and plan out how much time you want to spend running each of those.
So getting to the time when the competition actually starts, by now, running and optimizing those benchmarks and the applications should be old hat, right?
Oh, yeah. They should have their routine all down as to how their approach is going to be.
Now, sometimes they're confronted with multiple data sets for a particular application.
Yes, and so you want to take a look at the data. I would suggest some type of initial QC. You know, you want to make sure you have good data. If they're going to put in bad data, maybe remove that, because it's not going to run.
That's a good point.
If you don't think it's going to run, then you don't use it. And also,
they haven't done that to them yet. But if you think something won't run, go ask them.
If you think and you try running it and you're spending too much time getting it to run, don't spend the time doing it.
Yeah.
If you're trying to run, it's not running. Ask them if this was supposed to be, if the data is good. And also, you may be able to do something such as sorting the data. It could be, if you know the application and you know what the data is supposed to look like to get the most efficient run, that maybe some type of simple sort that you do ahead of time before you ever run the benchmark.
That's a good idea.
Give you a performance improvement. And
maybe start with the lowest hanging fruit in terms of the data set. Start with the smallest one first.
Oh, yes.
Yeah.
As always, start with the smallest or the easiest and work your way up to the most difficult one. If you're hitting a wall, move on to the next data set.
Mm-hmm. And that's key. That's the thing, is you don't want to get a zero. You don't want to turn in a zero for any application. You've got to have some result.
Right. So if you're not getting one of the data sets to run, move on to the next data set. And turn and do as best you can, and then come back to it if you have time.
Yes. That's just like
taking a test,
exactly.
Right? If you're on a difficult problem and you still have the rest of the test to do, go on to the rest of the test.
Exactly. Good stuff. Any other thoughts that we haven't covered?
I think we've covered a lot. I think it's really most important to plan your time.
I think you're right.
How you use it, because having an approach, how you're going to allocate your time, and also having the steps that you're going to do to both profile and tune the benchmark as well as set up the machine will really give you an edge in the competition. The
practice is really going to pay off.
Oh, absolutely.
Yeah.
Practice always pays off.
Now, you're not going to be at ISC, but you will be at SC, right?
Yes, we have our booth at SC17. So
Oh,
I
excellent.
hope, yes, I hope everybody will stop by.
Well, and I want to give you a tour of the student cluster competition at SC too. So we will definitely hook up and do that.
Oh, I would like that.
Take you through, introduce you to the kids. You'd make a good judge, in fact. Maybe we'll do that in some other years if you have the time.
Oh, I would definitely love to hear about doing that.
Yeah.
That would be great.
Lots of fun. But we will get you a tour in for SC17, and you've given these kids a leg up for ISC 17 and for cluster competitions until the end of time. So thank you so much for your time, Carolyn.
Oh, thank you, Dan, for asking me to participate.
Well, couldn't find anybody better. So there you go. Well, thank you very much, and thank all of you out there for listening. We appreciate it.